Good morning, children. In this session, we are going to study a new chapter, LCM and HCF. I know that you are studied this chapter in your earlier class. You are familiar with the LCM and HCF. Now, first, let us study what is prime factorization. Then we'll study LCM and HCF.
Study a new concept called prime factorization. What is prime factorization? Prime factorization is to write a number as a product of its prime factors. There are two methods to find the prime factorization of a given number. 1. Prime factorization by repeated division. 2. Prime factorization by building a factor tree. Let us learn them one by one. Prime factorization by repeated division. Find the prime factorization of 180. To express 180 as the product of its prime factors, we have to begin with the smallest prime number that divides 180. As the number 180 is an even number, it is divisible by 2. We write 2 to the left of 180 and dividing it by 2, we get 90, which we write below the dividend 180. Now we have to divide the quotient 90 with the smallest prime number. As the number 90 is an even number, it is divisible by 2. On dividing 90 by 2, we get 45, which we write below 90. Now we have to divide 45 by the smallest prime number. As it is an odd number, so it is not completely divisible by 2. So now we move ahead to the next prime number, that is 3. Number 45 is completely divisible by 3. 45 divided by 3 is 15. Write 15 below the 45. Number 15 is also completely divisible by 3. That is, 15 divided by 3 is 5. Write 5 below the 15. Now we have 5 as the dividend. It is itself a prime number. So, lastly, on dividing 5 by 5, we get 1. Write the 1 below the 5. Now we have 1 as a quotient. Now we write the prime factorization of 180 as the product of all the prime numbers that we have on the left. Thus, the prime factorization of 180 is 2 into 2 into 3 into 3 into 5. So, we have to follow 3 steps while finding the prime factorization by repeated division method. They are: Step 1. Divide the number by the smallest prime factor. Write the quotient below the dividend. Step 2. Continue to divide the quotient with the smallest possible prime number till the quotient is 1. Step 3. Write the number as the product of its prime factors arranged in ascending order. Now, let us solve one more example. Express 78 as the product of its prime factors. As 78 is an even number, it is divisible by 2. 78 divided by 2 is 39. Next, as 39 is an odd number, it is not completely divisible by 2. But the next prime number, 3, can divide 39 completely. So, 39 divided by 3 equals 13. Now, we have 13 as the dividend, which itself is a prime number. So, dividing 13 by 13, we get 1. Now, we have 1 as the quotient. Thus, the prime factorization of 78 is 2 into 3 into 13.
I divide 100 by 2. We get 50 as the quotient. We again divide 50 by its first prime factor, which is 2. We get 25 as the quotient. 25 is not divisible by 2 or 3. So we divide it by the next prime factor, 5. We get 5 as the quotient. We again divide 5 by 5. As 5 is a prime number, we get 1 as the quotient. Now, as we get 1 as the quotient, we stop the division. This way, we can prime factorize 100 as 2 into 2 into 5 into 5. Now look closely. All the numbers which we have written here to express 100 are prime numbers, right?
So, prime factorization is finding which prime numbers multiply together to make the original number. Here you can see some more examples. The way of writing 12, 14 and 8. 12 can be written as 2 into 2 into 3. That is 2 2s are 4 into 3 and 4 into 3 gives 12. So 2 2s are 4, 4 3s are 12. Similarly, 14 can be written as just 2 into 7. Both are prime. And 8 can be written as 2 into 2 into 2. That is 2 into 2 gives 4 and 2. 4 2s are 8. Is it clear, children? Now, let us understand prime factorization with some more examples. Now, as we have studied from this video, we have to divide 42 till we get 1. So, here 42 we have to write like this. Here 42 is an even number, isn't it? Because 42 ends with 2. So, in divisibility rule we have studied when a number is ending with an even number, that number is divisible by 2. So, we'll divide it with 2 and 2 is the smallest prime number, isn't it? So, 2 2s are 4, 2 1s are 2. Now, 21. 21 is not divisible by 2. So, the next prime number is 3. 3 7s are 21. Then the next number is 7. 7 is divisible only by 7. 7 1s are 7. So 42 can be written as product of 2 into 3 into 7. Prime factorization of 42 is 2 into 3 into 7. So our next example is 50. Now let's write 50 like this. We have to divide 50 till we get 1. So 50 is ending with 0, isn't it? 50 is ending with 0. So in divisibility test we have studied when a number is ending with 0, that number is divisible by 2, 5 and 10. But 10 we cannot take because 10 is not prime. So we can take either 2 or we can take 5. So now I'll take 5. 5 tens are 50. Is it clear? 5 tens are 50. So our next number is 10. So here also the number which divides 10 is either 2 or 5, isn't it? 2 5s are 10 and 5 2s are 10. So whatever number you want you can take. You can take either 2 or you can take either 5. I'll take 5 itself. 5 2s are 10. 5 2s are 10. The next number is 2. 2 is divisible by 2. 2 1s are 2. So therefore it's done. Now 50 can be written as the product of 5 into 5 into 2. 5 into 5 into 2. Product of prime numbers. So our next example is 63. Is 63 divisible by 2? 63 is ending with 3, isn't it? 63 is ending with 3. So it's not divisible by 2. Now next prime number is 3. For divisibility rule of 3 is we can add the digit and we can see whether 63 is divisible by 3 or not. 6, 7, 8, 9. Yes, 63 is divisible by 3 also, isn't it? 63 is divisible by 3. And 63 is divisible by one more number. That is 7 9s are 63. It is divisible by 7 also. It is divisible by 7 also. So either you can take 3 or you can take 7. I'll take 7 because I know 7 9s are 63. 7 into 9 gives 63. Now next, it is 9. So 9 comes in only 3 stable, isn't it? So 3 3s are 9. And then 3 1s are 3. So 63 can be written as the product of 7 into 3 into 3. 3 3s are 9. 9 7s are 63. Is it clear? The product of prime number, that is 7 into 3 into 3. So coming to the fourth example, that is 81. Let's write 81 like this. So just by looking the number, we know that 81 is divisible by 9, but 9 is not prime, so we cannot take 9. But can you tell me 81 is divisible by which number? We'll check the divisibility for 2. 81 is ending with 1, so therefore it is not divisible by 2. Is 81 divisible by 3? Divisibility test of 81, that is, it's a 2-digit number. Divisibility test for 3 is 8 plus 1, that is 9. Okay, we are getting the sum as 9. 9 is a multiple of 3, therefore it is divisible by 3. It is divisible by 3. It is divisible by 3. So we'll take 3. And if you don't know 3 into what gives you 81, you can just divide and check. 3 2s are 6. 3 7s are 21. So therefore 3 into 27 gives 81. Is 27 divisible by 3? Yes. 3 9s are 27. Again 9 is divisible by 3. 3 3s are 9. And then again 3 1s are 3. So therefore 81 can be written as 3 into 3 into 3 into 3. Product of prime numbers. So our next number is 135. So 135 is divisible by 5 because the number is ending with 5. It is also divisible by one more number, children. Can you guess which prime number it is? Just add the digits. 5, 6, 7, 8 and 9. We are getting the sum of the digits 9. 9 is divisible by 3, isn't it? So therefore, we can say that 135 is also divisible by 3. So we can take 5 or 3. Now I am taking 3. Now let's divide and check what is the answer. 135 divided by 3. 3 4s are 12. 3 5s are 15. So I got 45. 45 is divisible by which number, children? 45 is divisible by 5 and also it is divisible by 3. So I'll take 5 because I know that 5 9s are 45. 5 into 9 gives 45. So that was easy, isn't it? Now next is 9. So 9 comes in which table, children? It doesn't come in 2's table. Does it come in 3's table? Yes. 3 3's are 9. And then next is 3 itself. 3 1's are 3. So therefore 135 can be written as 3 into 5 into 3 into 3. Product of prime numbers. So our next example is 300. So 300 is ending with 0. So 300 is divisible by either 2, 5 or 10. 10 we cannot take. So the rest remaining numbers are 2 or 5. So we can take 2 or 5. So I am here taking 5. Now let's divide and check. Or it's very easy. We'll take 30. 5 6 are 30. Then add the 0 here. 5 into 60 gives 300. 5 6 are 30 and then remaining 0 I have written there. 60. 60 is ending with 0. Again it is divisible by 2 or 5. We have to take only prime numbers. Remember, always take prime numbers. For prime factorization, take prime numbers. So again I can take 5. 5 into what gives you 60? 5 into 12 gives you 60. So next number is 12. 12 is divisible by 2, 3. Are there any other prime number divisible by 12? No. So we can take 3 or 2. I am taking 3. 3 4s are 12. Now 4 is divisible by 2. 2 2s are 4. Then 2 1. So 300 can be written as 5 into 5. 5 into 5. 3 into 2 into 2 into 2 into 2. Isn't this easy, children? So these are the homework which you have to do in the notebook, and also the 6 problems which I have shown you in the video, that also you have to write in your notebook in order to understand it better. Okay children? And then thank you.